All right, yeah, thanks. So for my Keystone topic, I chose to do a project in the major, and this is for the engineering college for specifically computer and electrical. And the name of my project is Smart Oil, and we'll get right into it. So the main question we wanted to answer with this project is, how do you design a full home energy monitoring system for homes that heat with oil? This might not seem like a topic that would be useful for today, considering we're moving away from oil and towards more renewable sources. But actually, if you look at the data, this is from the EIA from 2009, you can see that around 40% of homes in New England are currently still heating with oil. And that's a pretty high number. So we wanted to address that in our project. So if you take a look at this picture, on the left side, you'll see a pretty old looking heating tank. And this is what most oil tanks look like nowadays. They generally don't look very updated. They're not really the newest technology. And if you look at that on the right side, you'll see a scaled up picture of an analog temperature sensor. Sorry, not temperature, an analog height sensor. That's supposed to tell you how much oil is left in your tank, and it's pretty hard to read. So our project aims to actually aid in this endeavor of reading how much oil you have in your tank, but it goes into a lot more depth as well. So the goal of the project is to develop a smart system for homes that heat with oil for retrofitting to cut consumption. Why do we want to do this? Because oil tech is outdated and it's inefficient, and we want to decrease the amount of oil that homes are using. And of course, it's targeting mainly homes in the Northeast of the United States because that's the area of the country that most use oil for heating. So the solution that we came up with involves three main parts. There's a sensor network, which records the data from different parts in the house. There's an iOS application, which the user will be able to real-time check all their information, which I'll go into more detail later. And then there's going to be a predictive modeling portion of the project as well. That's so that the user can predict how much oil they have left in their tank. So this is sort of the timeline that my group and I followed throughout the year, starting all the way back in September with the definition of the project and leading all the way up till now with what was supposed to have been the final installation, but I can get more into that later. So here's a system overview. So on the left, you'll see the model of the system that we designed. And on the right side, you'll see a couple of you'll see the sensors that I can walk you through really quickly here. So on the top right, there are zone temperature sensors, and those go in each of the heating zones in the house. So the way oil heating works is each zone, there are a couple of zones in the house that all sort of get the same distribution of heating, and we put a temperature sensor in each of those zones. That information is relayed to the central controller, which you can see on the right middle, and that information is sent then to the user, which they can check on their app. On the bottom right, you'll see an ultrasonic sensor, which also relays information to the controller and then to the user. This is just an overview. It's a pretty detailed block diagram of the system that my group and I designed. And so you see on the left, you'll see the sensor network, which is what we showed in the previous picture, but instead it's shown in block form. You'll also see the iOS application, and you'll also see the server and the database. These are all pretty integral components in the smart system. So on that timeline, you'll remember that we had a second prototype test, and our goal for this test was really to have a minimum viable product in order to install it in the customer's home. And so what you'll see, I kept the picture on the left for reference because I think it's a good tool to actually understand each of the components when I talk through them. So on the top right, you'll notice there's a big bucket on the floor, and that's actually filled with water. That's our attempt to simulate an oil tank in the home. And so what you'll see in the middle is there's a little ultrasonic sensor that's attached to a piece of cardboard, and that's what you'll notice on the bottom left, attached to the oil tank. And of course, that's communicating via Wi-Fi to the controller, which on the bottom, you'll see the results from. You'll see a time series graph with an actual needle showing the amount of oil in the tank. And then there's another little bit there that says 67.83 degrees Fahrenheit. That's coming from the temperature sensor, which is a little bit above on the top right corner, a little bit above the ultrasonic sensor. So this is our prototype test, which basically shows proof of concept and is essentially a minimum viable product, because you could pull this up on your computer and actually look at how much oil you have in your tank, and you can look at the historical data of how much you've used, and you can even see what temperature it is in whatever zone of the house you've installed the sensor in. So now let's take a look at the software components of the project. So of course we needed an iOS application. Our client specifically wanted iOS rather than Android. That made it a little more difficult for members like myself and one other who only had an Android, but we figured out ways to work around this with virtual testing and computer emulators. But the basic purpose of the application was to send and receive data from the database. And that's so that we could display data for the user to see, for example, on the right, you'll see the oil tank level and the temperature of the heating zone in that house. So this is a pretty good graphic that we have to basically to demonstrate the user journey. So this is what happens when you actually open up that application on your phone, and you can look at all these different things. So you log in, it checks your credentials. If it's invalid, it sends you back. Otherwise, you can check out all these different pages. We have home status, historical data, time plots, prediction center, and then of course settings. And settings is a pretty interesting point because we actually have, the way we calculate the amount of oil you have in your tank is extrapolated from the shape of the tank. And so the user will actually input the data for the dimensions of their tank, and it's customizable in that way. So you could have any shape you want. You could have a triangle, a square, a rectangle. As long as you tell our algorithm what your dimensions are, we can calculate exactly how much oil you've used. So still with software, we have the server. The server's job is to basically grab the data from the sensors via Wi-Fi and then send it over to the database, which we designed in MySQL for now. On the bottom right, you'll see the block diagram I showed before. And I kept this here also because it's a good way to just keep in mind the scope of what we're doing here. And so on the left side, you'll see this is the parsed output of what the database receives from the server. It comes into it like a big jumbled mess, and we actually have to sift through it and put it into a presentable form so that the database can understand, and then so that even we can understand it, because oftentimes it's hard to understand what data comes out. So let's get into the algorithmic analysis. This is a very exciting portion for us. So there's two parts for this. There's actually three parts. I'll start with the first. The first is how much oil is being consumed, right? So we wanted to be able to easily tell the user exactly how much oil has been used in their tank. And this is done, like I said, through calculations based on the dimensions of the tank. For example, we currently are doing it for a standard cylindrical tank. However, the app has options for the user to enter exactly what shape they have and to put the dimensions of it so that we can easily calculate it for them. The next question we wanted to answer is how efficiently is the oil being used? We do that through the EUI index, and we can do that based on region. So for example, in Boston, the number is 40 to 50. We can set a certain threshold, and the user can also change that threshold. So if you go above that number, we send them a warning. We say, your efficiency is really not good this week, or this room is really hot, and it's causing your efficiency to go below what it should be. And so that's a really useful component, and it's important for the user to see which rooms in their house are getting too hot or using up too much oil, or etc. And this is a very exciting portion as well. The third portion of the algorithmic analysis is the predictive modeling. So if you take a look at this graph, it seems like a lot at first, but I'll break it down for you pretty easily. So this is a data set from 2000 to 2020. What we did here was we chose this data set because it exhibits seasonal qualities and cyclical qualities. That means that it sort of trends up, and it also repeats year after year. This is what we thought an oil trend would look like in a home. Because we didn't have actual data to work with for how much oil was being consumed in a home, because we're sort of the first people to do this, we had to choose a set that we thought would exhibit this the best. And so what we did here was we used predictive modeling to determine what we expected the output to be for the next couple of years. So in 2018, we broke off the data and then we predicted the rest. And it's pretty accurate here. You'll see that the actual in orange and the forecast was in green. So it's pretty accurate. So in terms of our next steps, we've got a few different here. I'll leave them up and I'll finish speaking right now. I think that's about 10 minutes. And if you have any questions, I'd love to answer them. Thank you.